Hello everybody, welcome back to Dev Actualized. Today we're going to be talking about Big O notation, which is a crucial concept in computer science and software engineering. Big O notation allows us to quantify the performance and efficiency of algorithms in terms of their time complexity as well as space complexity. In simpler terms, it's just a way to measure how quickly and efficiently you can make your code. So the Big O notation is represented by these expressions here, and the two simplest ones to remember are Big O of 1 and Big O of n. Starting with the fastest and least memory intensive, O of 1 represents constant time. This would be like if you had an equation that regardless of input size, it always takes the same amount of time to return the data. For example, returning the index of an array. Even if your array was 1,000,000 numbers in length or 3 numbers in length, it would still take the exact same amount of time to complete. This is an ideal situation. O of n is rather simple to remember as well. It's linear growth, which means that the length of time it takes to compute grows in accordance with its input size. Think of it like this. Let's take an unsorted array. In the worst possible scenario, you would have to traverse through the entire array to find a certain element. So for each extra unit of input, so too is there an extra unit of time. This would be considered linear growth time complexity. Next is O of log n. O of log n is less efficient than O of 1, but more efficient than O of n. And the reason it's more efficient is because it operates on a constantly reducing data set size. Imagine a book with its entire contents as printed numbers that are in order from 0 to 1,000,000. With O of n, you would need to read every page in that book, but with O of log n, you cut the book in half each time, thereby narrowing your remaining search volume by a significant amount. Next, we have quadratic space and time complexity, or n squared. This is where the output, or time, would be the square of the input. Put in simpler, more human terms, it's like that age-old handshake problem when there are 8 people in the room and each person has to shake hands with all the others one time. Except in our case, they're all full of self-love and shake hands with themselves as well. Lastly, we have exponential space and time complexity. This is the kind of function that grows very rapidly with increasing values of n, and ideally is a complexity you want to steer clear from unless absolutely necessary. Exponential time and space complexity indicates that the resources required for an algorithm's execution double with each additional input element. This is like the old Greek mythological tale of Hercules fighting the Hydra in the 12 labors. Each time he cuts all of the heads off, 2 more grow in their place. So, things to remember, Big O notation always goes by the way of the worst case scenario. So if we have a scenario where time or space complexity is O of n plus O of log n, we just put it as O of n, whichever is greater. It simplifies things and makes them a little bit clearer. Alrighty folks, that's it for today. Hope you were all able to get the basics of Big O notation. Please like and subscribe, and comment any questions or thoughts below. Have a great day!